Okay, so today's lesson is going to be on 4.3, how to rearrange formulas. So what this document has are just different examples so you can see how you can use algebraic steps while still considering SAMDEB and learning how to isolate for different variables. So there's a couple of key important things, so I'll just review the important section that I just highlighted here. So when there's more than one variable term, clear fractions by multiplying each side with a common denominator, so that's something that we did work on in 4.2. Expand the brackets if they exist. So if you have brackets, please use your distributive property steps. Collect the like terms that are on the same side of the equation. So remember, using your polynomial skills, you will be collecting all x's or all variables, whatever they may be, and collecting all constants, so all numbers that are by itself. Combine the variable terms on one side of the equation, and then combine the constant terms. So as I mentioned, terms without numbers on the other side of the equation. Okay, so what we've been talking about so far is this idea that there is this wall that exists. So for instance, for our first equation, we want to solve y equals mx plus b. So what I'm going to do is I'm actually going to draw a wall all the way down along the equal sign. And we want to actually isolate for the variable x. So this might look confusing because you have so many variables. You have a y, you have an m, you have an x and a b. And you might say, well, why are there so many letters? We're in math. Math shouldn't have letters. Well, for today's class and other classes, there are lots of variables in mathematics, as you know. So if we want to isolate for x, that means you want to get x by itself. Okay, so to do that, you're going to consider your steps for SAMDEB. So SAMDEB stands for oops, that's not a good color. Here we go. We're going to do subtraction, addition, multiplication, division, exponents, and brackets. Okay, so in that order, there is no subtraction, but there is addition. Okay, so we have that add b. So because we want to isolate for x, I'm actually going to take that plus b, and I'm going to bring it all the way to the left side. Okay, so once I bring plus b to the left side, remember our steps and what actually happens. So I'm going to have y minus b is equal to mx. Okay. I'm going to once again highlight my x so we can keep in mind of our goal, which is to isolate for x. Now the operation that stands on the right side is m times x, and we know it's multiplication because they're beside each other. So the opposite of multiplying is division. So what we're going to do is we're actually going to divide both sides by m. Okay, what happens on the right side are the m's cancel. X is now isolated, and on the left side I have y minus b over m. Okay, so remember, isolated means get the term to its own side by itself with nothing around it. Okay. So that was a two-step equation because we first subtracted, which was to undo addition, and then we divided, which was to undo multiplication. Okay? All right, we'll move on to B. So for B, we have the exact same idea where we have D is equal to S times T. So you might recall this might have been something you saw in science class where distance is equal to speed times time. Okay, so the question is, how would you isolate for S? So once again, I'll write SAMDEB on the right side. And we can analyze SAMDEB and say, well, you know what? We don't have any subtraction. We don't have any division, but we actually have multiplication. And the multiplication is S times T. Okay, we want to isolate for S. Oh, I can highlight that, so I'll just wait. So if I want to get s by itself, I need to divide both sides by t. A common mistake is students will divide both sides by s, but then we want to isolate for s. Okay, so we don't want to divide by the term that we're trying to isolate for. We want to divide by the one that's beside it. Okay, so what happens here is we have st divided by t on the right side. The t over t actually cancels. And I'm just left with t, with s, and that's equal to d over t. Okay, so this was a one-step problem where we used division to undo multiplication. We'll take a look at one like C now. Okay, hopefully you guys are carrying and understanding the lesson so far. So for what we have for 1C, we have W is equal to U plus AT squared. And what we actually want to isolate in this case is A. Okay? So we'll analyze again our knowledge of SAMDEB. Okay, so in terms of SAMDEB, we actually do have addition. And that addition is the U. Okay, so we're going to bring the U to the other side. We have U plus AT squared. I'm going to keep AT squared on the right side. And I'm going to bring that positive U over the equal sign, so I should have W minus U. Okay. Now, I want to isolate for A. So once again, how can I get A by itself? Well, on the right side, I do have multiplication because I have A times T squared. So to undo multiplication, we must divide. Now, if I want to get A by itself, what's beside it is T squared. So I'm going to divide by T squared to the right side and divide by T squared on the left side. Like we saw in the examples earlier, t squared over t squared cancels. So I'm actually just left with A, and then I have W minus U over t squared.
It's nice out. Sun's out. Are you working out too?
Now for the remaining ones that are on this page, I'm just going to work through it so you can see exactly what happens. Okay? And you can kind of consider what would happen if you were doing it on your own using SAMDEB. For D, we have distributive property that we have to apply because we have P multiplied by 1 and then P multiplied by RT. So P times 1 is P. P times RT is PRT. Going to move this single P to the left side. I now have A minus P is equal to PRT. I then want to isolate for T, T, T. To get T by itself, I need to divide both sides by PR. These cancel. I'm left with T is equal to A minus P over PR. Okay. I'll do these last two here. We have that division sign, so in our steps above, it says if we want to clear fractions by multiplying each side, we have to find a common denominator. So our common denominator is 2, so I will multiply both sides by 2. Right side cancels the 2, so I'm left with BH is equal to 2A on the left side. Because I want to get H by itself, again, I will divide both sides by B. So these cancel, and H is just 2 over A over B. And F's pretty much the same as 1A, except now you're isolating for B. So this walks you through how to work through 4.3. Again, it is a little bit challenging because you have to have a really clear understanding of 4.1 and 4.2 to work through these successfully. So take your time, be patient with it. The solutions are at the bottom of this page. There's a couple extra ones here. However, I would like you to focus on your 4.3 homework that I posted today. But if you finish early and you want to try a couple more challenging ones, you could always just work on the second page. And your answers are, of course, at the very bottom right here. All right, so that's pretty much the end of 4.3. I want to wish you guys a very happy Easter, and please continue to ask me questions as they come up. Take care.